Hello, and welcome back to another CodingBytes math speedrun with me, Vince. Today, we're going to be going through Chapter 1.2 of the IBHL Math Analysis textbook. And this, I think, will be a two-parter since this chapter covers both arithmetic sequences in series and geometric sequences in series. So, we'll be tackling arithmetic sequences first. Let's jump right in. Yeah. So, first, we want to define what is an arithmetic series. And an arithmetic series is a series where we can get the next term, say this is un is equal to x. We can get the next term by adding a number to the previous term. And the number we add is called the difference, which we label d. And so this series, sorry, n plus 1, this series will grow arithmetically. It will grow by a certain amount each time we increase the term. So the way we define an arithmetic series, or the general formula for all, is we say that the term, the nth term, is equal to the first term, which is a constant, plus n minus 1 times d. So we gotta, to understand why this works, the first term is obviously just the first term. Then the second term is equal to the first term plus the common difference between the terms. And then the third term is equal to the second term plus the common difference between the terms, which is equal to the first term plus 2 times the common difference between the terms. And so that's why it's n minus 1d. Okay, now that we've got that covered, we can move on to, well, the other thing we need to know before we start on the challenges is how do you find the sum of an arithmetic series? So to get the sum, which we label S of n, so this is like the series, sorry, to get the sum of an arithmetic sequence, not series, which is the series, we can write this, the sum of this sequence until this term. We always assume that the sum starts from the first term and ends on this term, but we can modify it to adapt to otherwise. This is equal to the number of terms concerned divided by 2 times the first term plus the nth term, or the term at the final position. And what this is doing is actually, it's probably better to write n over this divided by 2. What this gets over here is this is getting the average of the first and last terms, and since it is an arithmetic series, this will give the middle term. And since on average, each term, like if we add them all up, will be equal to the middle term, we can simply multiply the middle term by n to find the sum, because the terms higher than the middle term will balance out the terms lower than the middle term, and they will all cancel out. So on average, the average value of the entire series is the term in the middle. So we can rewrite this a little, since we know un is equal to u1 plus n minus 1 times the common difference. So this is also equal to, oh, sorry. I need to bear in mind where you guys can see me, because I have the camera on. So this is also equal to sum of n is equal to n over 2 times 2 times u plus 1 plus n minus 1 times d. There we go. So this is the sum of an arithmetic series. Okay, now once we've got that covered, we can jump into some practice questions. And if you don't understand, maybe what I'm talking about when I'm talking about arithmetic sequences or series, watch on for a bit more, because jumping into some problems will actually make it easier, in my opinion, to understand what's going on. So as always, we'll do the first problem and the last problem from each question. So for the first question, we need to find the nth term. Let me just write this out. Find the nth term, nth term of each of these sequences. And our first sequence is 3, 8, 13, 18. So as we can see here, the difference between each term is simply 5. And so we know the common difference, d, will be equal to 5. So now we just have to find the general nth term. So we know that it's going to be the first term, which is actually 3. We already know it. So the first term is 3, and the common difference is 5. So we know that the nth term must be 3 plus n minus 1 times 5. It's as simple as that. So that's the first question done. Now on to the next question. Nope. So the last series is negative 20, negative 5, 10, 25. And as with the previous one, we can simply get the difference between the terms, which is 15 in this case. And so we have a common difference is 15, and our first term of this sequence is negative 20. So we have the general nth term is equal to the first term, 20 plus n minus 1 times the common difference, which is 15. Oh, sorry, negative 20 plus n minus 1 times 15. And this is our answer. That's it. So that was pretty simple. Let's move on to some harder challenges, hopefully. So, okay. So what's our next one? We need to find the terms indicated in each of these arithmetic sequences. And the first one is 5, 11, 17, 23, and we need to find the 15th term. Okay, so we'll do this by first getting the nth term. We know that the first term is equal to 5, and the common difference is equal to 6. So we know that for the nth term, un is equal to 5 plus n minus 1 times 6. And so we need to find the 15th term, so we'll simply plug in n as 15. So u15, the 15th term, is equal to 5 plus 15 minus 1, which is 14 times 6. So this is equal to 5 plus, it's 14 times 6, 24, 84. Oops, a bit slow today. So that's equal to 89, and that is our final answer. 89. And so let's move on to a more challenging one. Okay, so our next sequence is going to be D, so that's 16, 12, 8, 4. And we need to find the n plus 1th term. Okay. So this shouldn't be too hard. Oh, sorry. So we simply need to the first term is 16. The common difference is negative 4 because it's 4 between each of these numbers. And so our general formula, un is equal to 16 minus n, plus no, I'll keep it as a minus. Minus n minus 1 times 4. So, yeah. So to get the n plus 1 term, which we just need to sub in n plus 1 for n over here. So 16 minus n minus 1 plus 1, n minus 1 plus 1 times 4. So that's simply 16 minus 4n. And that's about it. This is the n plus 1 term. Okay, let's move on to the next challenge. So that would be, we need to find the number of terms in each of these arithmetic sequences. And the first one is 16, 11, 6, and it continues until negative 64. Okay, so it's a bit trickier problem. So we still have the first term is equal to 16, and the common difference is equal to negative 5. So in these kinds of problems, you always kind of want to find the nth term first, and then you can usually work out whatever you need to work out from then. So you have the nth term is equal to 16 minus n minus 1 times 5. And to find which term is negative 64, we simply substitute negative 64 as the value of the nth term, and we equate it to 16 minus n minus 1 times 5. So we have n minus 1 times 5. 5n minus 5 is equal to 16 plus 64, which is 80. So 5n is equal to 85, and therefore n is equal to 17. So in total, there are 17 terms in this sequence. And yeah, that should be right. So let's move on to another challenge. We want to still find a number of terms, but our series this time is 2a plus 5, 2a plus 3, 2a plus 1, until 2a minus 23. So this one looks a bit complex, but as you can see, it will still be easy. The common difference is negative 2, and we have our first term is 2a plus 5, and our difference is negative 2. So we have the nth term as 2a plus 5 times minus n minus 1 times 2. So our last term is 2a minus 23 is equal to 2a plus 5 minus n minus 1 times 2. And immediately here we can just cancel out the 2a's on both sides. And we can bring this over to this side and bring this over to this side. So we have 2n minus 2 is equal to 5 plus 23, which is equal to 28. So 2n is equal to 30, n is equal to 15. And so this is the answer. There are 15 terms in this sequence. Okay, let's move on to the next problem. Okay. Oh. Okay. So the next problem is number 4. We need to determine the first term and the common difference of the arithmetic sequences that are generated by each of the following terms. So I'll put that up there. Oh, and of course, I need to put what the terms are for the first question. So the first question is 16, un is equal to 5n minus 7. So the first term is pretty obviously going to be, oh, interesting actually, wait. They haven't usually we write it as n minus 1, as we've shown earlier, but it looks like they just want us to substitute 1 into n. So the first term will be 5 times 1 minus 7, which will be, negative 2. So that's that. This is our first term. And to get the common difference between each of the terms, it's 5. Because the difference between each of the terms will be determined by, like, if we add 1 to n, how much will the result increase by? And the answer is 5, because n is being multiplied by 5 to generate the value of each term. So that one's pretty easy. Let's try maybe a harder one. So the sequence this time is 2a plus 2n plus 1. Okay, so straight away again, our first term is going to be 2a plus 2 times 1 plus 1, which is equal to 2a plus 3 plus 1, 4. 2, oh, no, 3, what am I doing? 2 times 1 is, of course, 2 plus 1 is 3. So this is our first term. And the common difference will simply be 2, because little trick, the common difference will be the coefficient of whatever n is being multiplied by. Yeah, it's going to be the coefficient of n. So those are the answers for that question. Okay, let's move on to the next one. Our next question is the sixth term of an arithmetic sequence is 37 and the common difference is 7. Find the first term and the nth term. Okay, so we know that the sixth term, u6, is equal to 37. But we also know that u6 is equal to, of course, the first term plus 5 times the difference. And that's because this should be n minus 1 times the difference, but since n is 6, 6 minus 1 is equal to 5. So it's 5 times the difference. So we have 37 is equal to the first term plus 5, and we have the common difference is 7. So 5 times 7 is 35. So we have the first term, is equal to 37 minus 35, which is equal to 2. Okay? And so therefore, the nth term will be un is equal to the first term, 2 plus n minus 1 times the common difference, which is 7. And so that will be the answer for the nth term. Okay, and so for the next question, we have the fifth term of an arithmetic sequence is 0, and the 15th term is 180. Find the common difference and the nth term. Okay. So we know the fifth term, which is equal to u1 plus 4d. Remember, 5 minus 1 equals 4, is equal to 0. And we also have the u1 plus 14d is equal to 180. Straight away, if we just subtract these two equations, we get negative 10d is equal to negative 180. So the common difference must be 18. Yeah. And so we need to find the nth term. So we know that the first term, plus 4 times the common difference, which is 18, is equal to 0. So the first term is equal to negative 4 times 18, which is equal to negative 72, if I'm not mistaken. Yeah. It's equal to negative 72. So the nth term must be, move this down a little. The nth term must be un is equal to negative 72 plus 18 times n minus 1. And yeah, got it. Okay, let's move on to the next problem. And so the next problem will be the sum of three consecutive terms of an arithmetic sequence is 24 and their product is negative 640. Find the three numbers. Okay, so I guess I'll do this the long way. If the sum of the three terms is 24, then the trick is we can treat the first term, like the first of these consecutive terms, as just the first term of the sequence and calculate it from there. And you'll see this won't make a difference. So say u1, which is the first term, plus the second term, which is u1 plus d, plus u1 plus 2d for the third term is equal to 24. So anyways, 3u1 plus 3d is equal to 24, and the first term plus the common difference, or the second term, is equal to 8. This should be pretty obvious. It should be the average of the three numbers equal to 8, and the average of the three numbers should be the second term. Now their product is negative 640. So the first term, times, well, we could put u1 plus d here, but since u1 plus d is 8, we'll substitute 8 into here. So this is simply 8u1, and then we multiply this by u1 plus 2d. But again, this is equal to 8 plus d. So we can substitute 8 plus d here. So 8 plus d. And actually, because we want to eliminate all of like the first term, just get it to one variable, we can substitute u1 is equal to 8 minus d. So we have 8 times 8 minus d times 8 plus d is equal to 640, a negative 640. And if you have done maybe some algebra or some quadratics before, you'll know that this evaluates to 8 times 64 minus d squared, because difference of two squares. Or this is also equal to, well, what's 8 times 64? 512 minus 8d is d squared is equal to negative 640. And so 8d squared is equal to 512 plus 640. And at this point, I would suggest pulling out a calculator to calculate d squared is equal to, what is this, 1152 divided by 8. I guess I could technically do this. You know what? Why the heck not? Practice some arithmetic, because it will be useful later in the course. So we have 8 into 1152. That's 135. 4. I don't think I need to teach you how to do like basic arithmetic. Okay, so d squared is equal to 144, and therefore d is equal to 12. So the common difference in this series is 12. So let's go all the way back up. We now know that the common difference d is equal to 12, and we know that the second term was 8. So u1 plus d is equal to 8. Since you know this is 12, we know that the first term must have been equal to negative 4, and the third term must have been equal to 12 plus 8, 20. So is this correct? Yeah, it is correct. So the first term is negative 4, the third term is 20, and the second term, in case you weren't listening, is 8. So that's how you solve this problem. Yep, find the three numbers, so we've solved it. Okay. Now on to the next problem. So we have Jung Ho earned three. I don't have the euro sign, so I'll just call it in dollars. $38,000 when he started his first job in the year 2000. He received a raise of 500 each consecutive year. Wow, okay. Determine how much he earned in 2017, and also evaluate in which year he would earn more than 50% of his salary for the first time. Okay, so pretty simple problem. So you earn 38Ks, and we need to calculate how much he's earned in 2017. So we know the first term, which is in this case 2,000, it will just be 38,000. So we can call U1 is equal to that. Now notice the 2017 will actually be the 18th term, since we're counting 2000 as the first term. Similar to, like, coding where you start arrays at 0. So U18 is equal to 38,000 plus 500, which is the common difference, times n minus 1, so 17. So this is equal to 38K plus 80,500. If my math isn't wrong, which is equal to $46,500. So that's how much he earned in 2017, and we need to calculate which year he would have earned. The first year he would have earned more than 50% of his salary. So the trick to doing this is simply, what's 50% of his salary? It's 38,000 divided by 2, which is equal to 19,000. And what's 19,000 divided by a common difference? That's equal to 500. That will be equal to 38, if I'm not mistaken. 190 divided by 5. Yeah, because so it should be 38. And so to the first year where he earns 150% of his salary is 2038, but we need to know the year where he earned more than half his salary. So that would be the year 2039, since we need to add a year so that his salary increases past the 50%. Okay, we're getting on to the final few problems of this problem set. Okay, so okay, so we have the ninth problem. Find the value of each of the following series. And remember, series are sequences added together. So our first one will be 3 minus 3 minus 9 minus 15 minus 21 ... minus 93. So first we want to find what's the nth term of the series, and it's pretty clear the nth term is equal to 3 minus 3 times n minus 1, or I guess we could simply rewrite this into 6 minus 3n. And so now we need to calculate the last term, which term this is, so we can calculate the sum of the series. So we have negative 93 is equal to 6 minus 3n. N is equal to 6 plus 93. 3n is equal to 6 plus 93. So n is equal to 6 plus 93 divided by 3. That's equal to 2 plus 31, which is equal to 2 plus 31, which is equal to the 33rd term. So we're summing the terms from 1 to 33. And so remember, S of n is equal to n over 2 times 2u1 plus, well, actually, no. In this case, it would just be easier to go just the first term plus the nth term. So since we're summing to 33, we're going to put 33 divided by 2 times, the first term is 3, and the last term is negative 93. So it will be 33 divided by 2 times negative 90. Otherwise, 33 times 40, negative 45. 33 times negative 45, which is equal to, let me just erase this here. I guess you could pull out a calculator at this point as well, but I'm going to try not to. So 33, 45, well, 3 times 5, 15, 3 times 5, 16, 4 times 3, 12, 4 times 3, 12, 13. So 5, 8, 4, 1. Negative 1,485 should be your answer. I hope I haven't got this wrong, but if I have got it wrong, let me know. And we'll move on to the final three problems, I think. Okay. Erase all of this. Okay. So this problem will be, instead of this, we need to find the sum of the series a minus 1 plus a plus 2 plus a plus 5 until a plus 146. And so it's pretty clear that the common difference between the terms is equal to 3. And because a stays the same, so the common difference is just 3. So the formula must be a minus 1 plus n minus 1 times 3, otherwise known as a plus 3n minus 4. Is that correct? Yeah. Okay. So to get the value of this term, we need to substitute a plus 146 is equal to a plus 3n minus 4. Straight away, cancel out the a's, and then we have ourselves with 3n is equal to 150, n is equal to 50. So we just find the sum of the first 50 terms, which is fine. Since we have the first term and the last term already, we might as well put the sum of the first 50 terms is equal to 50 divided by 2 times, this is the first term, which is a minus 1, I think. Yeah. And then the last term is a plus 146. So this will be equal to 25 times 2a plus 147. Sorry, is this 147? No, it's 146. Okay. Yeah. And so this would be equal to 50a, which is what we would expect if we're summing 50 terms with 1a in each of all of them. We would get 50a plus, well, 147 times 25. I think it's time to pull out a calculator. Of course, we could do this without a calculator, but we want to be focusing on practicing like what we're supposed to be learning and not basic arithmetic. So this is 3,675, and so this should be the final answer. let's move on to the last two questions, which involve our friend sigma notation from last lesson. So this would be equal to, so our problem here is find the value of each of the following sums. Okay, so we can simply say this is a sigma symbol, and the first question involves a series ranging from 1 to 50, and it's equal to 3r minus 8. Okay, so we know that the sum of this is, well, we'll go from 1 to 50, and this will be equal to 50 divided by 2. And then let's get the first term, 3 times 1 minus 8, negative 5, plus 3 times 50 minus 8, 142, which is equal to simply 25, oh, why is that in green? 25 times 137, which is equal to 3,425. So yeah, easy peasy. Now, let's go on to the final question. And the final question of today will be, of this episode, will be ours ranging from 1 to 20, and it's equal to 2ar minus 1. They love the variable a, don't they? So to find the sum of the first 20 terms, we need to go 20 divided by 2 and divided by 2 times first term to last term. So the first term will be, remember r is 1, so 2a minus 1. And then the last term will be 2a times 20, so 40a minus 1, plus 40a minus 1. So this is equal to 10 times 42a minus 2, otherwise 420a minus 20. And that is the final answer. So, oh, there are actually more questions. Good thing I scrolled down. Let's have a peek at some of those. Hopefully they'll be a bit harder. So we need to, let's go for the first question. Find the sums of the following sequences up to the term indicated. And the first one is 4, -1, -6, and then the 15th term. Okay, so this is where we want to be using the slightly different form of notation. So the sum to the 15th term is 15 over 2 times 2u1 plus n minus 1d. And in this case, the first term, u1, is equal to 4, so 2 times 4, plus n minus 1, 14 times the common difference in this case being -5. So this is equal to 7.5 times 8 minus 70, which is equal to, get the eraser out, it's equal to 7.5 times -62, and we'll pull the calculator out for this one. 7.5 times 62, it's negative 465. So that will be the answer for the first problem. Okay, so on to the next one. Instead, we need to find the sum of the sequence 1, negative 4, negative 9, until the 20th term. And so this will be sum of the first 20 terms is equal to 20 divided by 2, which is 10, times the first term is 1, so 2 times 1, which is 2, minus n minus 1, 19, times the difference, which is common difference is negative 5, equal to 10 times 2 plus, oh sorry, this should be plus, what am I doing? 2 plus 95, which is equal to simply 970, or at least negative 970. Wait, oh, hold on. This is 2 minus 95. So this should be negative 930. And that's our final answer. Okay, on to some more problems. Okay, want to calculate the sum of an arithmetic series with 25 terms, given that the fifth term is 19 and the 10th term is 39. So first we want to find the actual series, and then we can calculate the terms. So fifth term is 19, u1 plus 4d is equal to 19. 10th term is 39, u1 plus 9d is equal to 39. So we know instantly that 5d is equal to 20, and the common difference is equal to 4. So the pattern for our series, so we need to find the sum of the first 25 terms of, the first term, we should calculate the series first. What am I doing? So we know that u1 plus 4d, but d is 4, so that would be 16, is equal to 19. So we know that the first term is equal to 3. So we now want to calculate the sum of the first 20 terms of 3. The sum of the first 20 terms will be, well, 20 over 2 for starters, times the first term is 3, so that would be 6 because we have to multiply it by 2, plus the common difference is 4, so it would be 19 times 4. And so this would be simply 10 times 6 plus 19 times 4. 19 times 4 is, what is 19 times 4? 38. 76 plus 6 is 82, I think. So this should be 820. Okay. So now on to the next problem. We want to where is it? Yep. We want to, the third term of an arithmetic sequence is negative 8, and the sum of the first 10 terms in this sequence is negative 230. Find the first term and the sum of the first 13 terms. Okay. So what do we know? We know that the third term is equal to 8, negative 8, sorry. And the sum of the first 10 terms is negative 230. So the sum of the first 10 terms is also equal to 5, remember 10 over 2, times 2u1 plus 9d, and this will be equal to negative 230. That's what they're saying. So we have 10u1 plus 45d is equal to negative 230. We can multiply this one by 10, so we have 10u1 plus 20d is equal to negative 80. So instantly we know that, what is this? 45d minus 20d is equal to negative 230 plus 80. So we know that 25d is equal to negative 150, and so d is equal to negative 6. So what's the first term then? Well, u1 plus 2d, remember, which is 2 times negative 6, is equal to negative 8, so therefore u1 should be negative 4. That's it. And therefore, we need to find the sum of the first 13 terms. Okay, so the sum of the first 13 terms is equal to 13 divided by 2 times 2u1 to 2, sorry, this is 4. 2 times 4 plus, or in this case, plus 12 times negative 6. And this should be equal to 13 over 2 is 6.5 times 8 minus 72, which is, of course, negative 64. So 6.5 times negative 64, which is equal to negative 416, and then that should be our answer. Okay, I think we're doing quite well. So let's move on to the next one. Eraser all of this. Okay, on to the last two problems. First, the problem is the sum of an arithmetic series is given by sum of that is equal to 6n minus 3n squared. Find the common difference and the first four terms of the series. Okay, so they're giving us that Sn is equal to 6n minus 3n squared, but we also know that Sn is equal to n divided by 2 times 2u1 interesting. Okay. 2u1 minus n minus 1 times the difference. So what we really want to do is expand all of this. So we have n times the first term minus n squared times the common difference divided by 2 plus n times the common difference divided by 2 is equal to what we have up there, which is 6n minus 3n squared. And straight away we can see that because these two are the only two terms with an n squared in them, negative 3 must equal negative d over 2. So the common difference must be equal to 6. Is that correct? Yeah? I think that's pretty straightforward. And so finally, we need to find the first term. So we have 6 is equal to the first term plus the common difference divided by 2. And since we know that the common difference divided by 2 is -3, we should have, is 3, then we should have the first term is also equal to 3, which is a bit odd. Am I sure I got this correct? Okay, I'm back. Very sorry, but I've been a massive idiot, and I forgot there should be a plus sign on a minus sign, making this a plus and this a minus. And so therefore, the common difference should actually be -6. But the first term is still equal to 3, since 6 is equal to the first term plus the common difference over 2, which turns out to be -3. Oh, actually, sorry. No, it does not turn out to be -3. Ignore what I said there. So, yeah, sorry, the common difference is equal to -6. And so we have 6 is equal to the first term minus the common difference, which is equal to the first term plus 3, plus the common difference over 2, so which is equal to plus 3. So the first term is still equal to 3. So we found the common difference is equal to -6. The first term is equal to 3, and so the first 4 terms will be 3, -3, -9, and -15. Easy peasy. Okay, now on to the last question of this. So the last question says that calculate the sum of all the odd numbers less than 300. So for those of you who don't know, the formula that generates odd numbers is 2n minus 1. So we need to just calculate the sum of the first 300 numbers that have a first term, of course, 1. Oh, sorry, not first 300 numbers. Oops. Okay, maybe this is a bit more complex. So first we want to calculate the greatest odd number is obviously 299, and so we need to calculate how many odd numbers are there between 1 and 299. So we know that 299 is equal to, what would this be? 1 plus n minus 1 times 2. So we have 2n minus 1 more or less. Yeah. So we have 300 equals 2n, and of course, n is equal to 150. So we have to sum up the first 150 numbers of this 2n minus 1 series right in front of me. So we have to sum 150, and it would be 150 divided by 2 times the first term, 1, plus the last term, 299. That's equal to 75 times 300, which is equal to 75 times 300. Yep. Which is equal to 22,500. And that should be the final answer. So I hope you've learned a lot from that speedrun. That's a speedrun of exercise 1B of chapter 1.2, which covers arithmetic sequences. And if you enjoyed it, maybe follow along for my next few speedruns. See you then.